Okay, so good morning, class. This is a mathematics class. So just to let you know that I'm going to cover example 3 of chapter 1 and then 4 and 5. And then tomorrow I will go through the tutorial, which is actually question 6 to 10, right? I will try to do question 6 and 7, and then the rest I can leave with you, okay, depend on this. Okay, so if you are actually not familiar with the trigo function, we still continue can revision trigo function. There are notes there. So I'm going to start from this example 3. Okay, start from this example 3 here. So let's how to interpret this example 3. So we read the sentence one by one, right? Just like last time I mentioned to you, you read the sentence one by one. So the first sentence says that the ship is steering at 037 at 10 knots. Okay, at 10 knots. So the first thing is, okay, so you can start drawing here, 037. So this is actually north pole here. That means 0 degree. Okay, so this is east, southwest. So 037 is about somewhere here at 37 degree. Okay, so it about 3 knots there, 10 knots, sorry. So 10 knots, 10 nautical miles per hour. Okay, 10 knots there. Okay, so this is for first thing, the ship. Okay, the ship actually move from here to here. The ship move here, right? Ship. So let's call A here. The ship is point A. This direction the ship goes there. And then the current is setting at 257 degree. So there is the current there. The current of the sea. Setting at 257 degree at 3 knots. So how to find this situation? The ship as it move around, it has a 10 knot there. So now I look at the current. Okay, how to draw the current here? So let me draw separately how the current look like. So here this is current here. The direction of the current. So this is north here, and east, southwest here. It's 257 degree. So how much 257? So this is 180, and 180 only, and then you need to add another how much that? So you need another one. How much that? Okay, I think it's a small angle here because you need 270 there. So that means that this 270, right? So this is 13 degree here. Okay, 270 minus 13, you get 257. This direction. And the current is 3 knot here. So let's join this diagram to here. Let's see, I join extend because I want to make sure that they are as accurate as possible. Let's say this somewhere here. So this is about current now. It's 13 degree. And is 3 knot. Okay, this is 3 now. Okay, direction of current is this one. All right, so the ship move in 10 knot in 37 degree. and then the carbon move 25, okay, 257 degree, okay, this 257 degree here, at 3 knot. So find the speed and the cost made good. So I have used different color here. So this is the different color. This is a yellow color here, and this is a blue color here. Okay, blue color, I think wrong color. That's right. So I want a blue color here. So what is happening is find the speed and the cost made good. So I want to find the speed and the cost made good. I can use quick color now. What they want is actually the ship, because it's moving at 10 knot, but then the current moving at 3 knot opposite direction, almost opposite direction. So the speed will be somewhere here now. The speed of the ship is, you need to know what is this length here. Okay, you need to know what is this length here, the speed here. So let's call this the current, this spot is called B here. Let's call this spot B here, on this spot C here, right? So the speed is actually 8. The length of AC is the speed now. So the speed is AC. Okay, the speed is AC here. And then the cost made good. So because of the current almost change the direction of the ship here, so the speed made good is actually this one. The direction, the cost made good, right, is this one. Okay, so the cost made good there. The actually eventually cost made good is actually this the angle AC, right? Angle AC. Okay, angle AC. Okay, so this is how you analyze a problem. Okay, so I think most people should be here already. Let's see who are here. Okay. How come there's so many people? I think people are still be here. Okay, so now let's go back. Okay. Okay, I think yeah, got the diagram covered already. So let's try to analyze the triangle now. Okay, we know what we want to find: the speed AC. I want to find the cost made good. All right. So let's go to the next page here and reproduce the triangle. So let me copy this page first. So I'm going to move to the next page here. All right. Okay, so I'm going to push the diagram aside here to show you more working. So let's move this diagram to the right side and then blow up. Okay, so what are the things we can find? So let's try to find out what is what do you know about angle B first. Then you can find what is actually uh, the speed may go like maybe. I'll try. So let's try to find angle first. So let me eventually I want to find the speed, right? So the first one. So first angle B. Do you know what is angle B here? So we know that this angle is 37 here. Right? This angle is 37, but because of this yellow one. Because of this yellow one, this angle is 37. So this is equal to 37. And then this angle is 13. Okay, 13. So angle B is what now? You know, from south to west. So angle B should be 90 minus 37 minus 13 degree, right? Two angle there. So from there, 37 plus 13 is 50. So this one is 40 degree. So angle B is 40 degree now. So this one is 40 degree here. Okay, so can we find what is the final speed AC now? This is where you can use the sine law now. So you can see AC corresponding to this is the C here. This point C, right? The C is here. And then this is actually, then this B here is AC actually the B here. B is equal to what, right? B is equal to what? So you can use the sine law here. So sine law say that, okay, B over sine 40, so B over sine B is equal to A. Do you know what is A here? Okay. B over sine B is equal to, okay, I think I need B I know already, and B I know, so it's a 3. Okay, so C is 10. So I know B I don't know, C is 10. So another angle, I need another angle, right? So B is 40. Maybe I need this one angle, maybe. So this is okay, let me see how I do this. Okay, B over sine B, something is missing there. Let me try to figure out more things first. Okay, something is missing here. So, okay, let me try this. Okay, so actually, I'm actually using, okay, so not sine law, okay, sorry. So I find that sine law doesn't work here. So actually, I know sine B, right? So angle is 40. So let's do find AC here. Okay, AC is actually, you can find the length first. Okay, so AC square, which is actually B square now. So B square is equal to A square plus C square minus 2AC cosine B. Okay, B is one, the side B is actually 1 to 5, right? B is how much there? Okay, that's B, right? So from here, A is on the current, that's 3 square. C is the speed of the strip there is 10 square. Minus 2 times 10 times 3 cosine angle 40. So then you calculate what is B square first. So I need calculator to count the answer. So this is 3 square by 10 square. So 3 square plus 10 square minus 2 times 10 times 3 times cosine 40 degree. Okay, so this is 63.03 formula. So that means that B, take the square root here, is actually take the square root here. Answer, you get 7.93 or 7.94 now. Okay, 7.94. Okay, not there. So I think anyone got a message there. All right, so okay, fine. So that is why they get 7.94 knots from here. Okay, so because a triangle, you want to find the third side now. Okay, first of all I try to do the sine law, but sine law I think I missed. I only have angle B. Okay, the rest of angle I cannot use, so that's why I use the cosine law now. Okay, just nice to fit in cosine law. So this is part, find the speed now. So this is 7.94, right? Next, I want to copy this question again to find out what is the cos make good there. Okay, direction of the street there. Okay, so next page down. Okay, so now I want to find the cos make good, all right? So I use a delete this B now. Okay, B is 7.94 now. So this is 7.94. Okay, so I want to find the cos make good, right? The cos make good is the red color one, cos make good. Then I want to find this. But before then, I need to find out what is find angle A first, right? You need to find angle A. Okay, so this is where the 7.94 will help you already, because angle A is A over sine of angle A is equal to B over sine of angle B. Okay, the triangle there. So the I don't know what is angle A. So sine A is equal to, okay, so sine A is equal to A times sine B over B. Now rearrange them. Okay, sine A is equal to sine A times sine B over B now, which actually A is actually 3 sine 40, and then B is 7.94. So you press the calculator, 3 times sine 40 over 7.94. Okay, then you find A now. Okay, so this is equal to 0.242. Okay, 0.2428. So that will tell you what is A now. So A is equal to, usually you press calculator, you press a shift, then sine inverse, right? Sine shift, then sine inverse. The answer and then this will give you 14. Okay, so this angle A is 14 degree. So this is 14 degree now. For this part here, this is 14 degree. So what is the final direction of the ship now because of the current? So this is equal to, the answer is, you want to find out there. So this is the final cos. Cos make good, right? So this one, the cos make good here. So cos make good is equal to, okay, you look at 37 degree. 37 degree is a yellow one, minus the A minus angle A, which is 14. Okay, minus angle A, which is 14 here. Okay, 14, I have this color here, 14. And so that's why you get 23 degree now. So the final cos is 0.23, right? So 0.23 true bearing. Okay, 0.23 degree true bearing eventually. Okay, final cos make good. Okay, so this is how you answer example 3. So if you have anything not clear, please let me know, or you want to go back to the previous page, or let me know, right? So I only intend to go through 3 examples today. So when you solve triangle problem or bearing question, you read one sentence at a time. Okay, one sentence at a time. So I think I have a different color system in this case. So I just withdraw it here. So in the beginning, this is how the question look like. Okay, first draw a triangle first, auto direction, the current. Then after figure out you need to find what is the speed AC, the length AC, and the angle. Okay, cosmic code is actually the angle from A to C. Okay, so from here, I use the cosine law because you observe what kind of law you can do with. Because we'll try the first, I try the sine law, then I get stuck. Okay, get stuck because I don't have enough information. So then you can try. All these are only 2 laws you can try. Okay, then after that I got the speed. Then already the vector, the AC. Okay, then I can find out the B come out already how fast the ship move. Okay, so actually the ship is moving at 10 knot. Okay, but then because of current, it slow the ship down because current is opposite direction now, almost opposite direction. Then because of current, the ship actually the direction also changed, right? Because of current. So you can find that from there, you can find the cos. I'm looking for the angle A. So this is example 3. So if you have any question, example 3, right? Then you go back some more. You can request, right? So I want to move on to example 4 now. Let's try example 4, right? Okay, I want a fresh page on example 4. Where is that? Okay, let me start from somewhere easier to start with. All right, I'm going to start from this page, okay? I'm going to start over fresh, okay? Fresh this one, okay? So let me edit, copy page first. Okay, so let me start from this page here. Okay, so let me erase all these questions first. Okay, example 4, a vessel steer at 050, two bearing at 5 knot. So this is the direction move. So let's say this is a beginning of a here. Let's say this is called A here. point here. So the ship is at this point. So this north here is west and south here. The ship is sailing at 50 degrees and 5 knots. So this is the first statement. So usually I use a yellow color for the first statement here. Okay. Okay, this is where beginning. So at the time is 5 o'clock here. So there's 150. Okay, the time in this case indicate there is 5 o'clock here. So if 50 degrees, so roughly like that. So 50 degrees here. 5 knots. Okay, then there are a few things. So this question is hard because they mix two things together. Okay, they are mixed two things together. So at 5 o'clock, the vessel observed the angle elevation of the top vertical tower. So somewhere there's a vertical tower. So let's say somewhere here, this B here. Okay, this actually, let's say somewhere here in the tower here. The tower is here. Let's say this is at the, we call it C here. So no, that's an issue. You can just name that. So tower. Okay, tower C. So there's a tower here. Okay, tower. The bearing of the tower is 0.15. Okay, so let's look at about direction first. Don't worry about the angle elevation. So the tower is bearing is 0.1015. Okay, so now let's right here 0.15. So the ship is moving at 5 knots at the point A, and observe there's tower, the bearing is 0.15. So maybe I should draw it nearer there. So I want to get tower here. So I try to get slowly so that it's more accurate picture. So I have from here to here is this angle is 15 for tower bearing, right? Now, after 10 minutes, okay, and once the bearing of the tower is 250 now. Okay, where is 250? So this is actually how to get 250 here. So to get let's draw it first. So north, east, south, west. Where is 250? So this is the third statement now. And 1710, 10 minutes later, is 250. So where is 250 now? 250 is quite easy to draw because this is 0, this is 90, this is 80, this is 250. So 250 is somewhere here, this direction. And this is happening at 10 minutes later. So 10 minutes later, I think the ship go into here now. Okay, 10 minutes later, the ship go into here now. And the direction is the tower from the ship now after 10 minutes, right? 1710 hour. And see the tower now is, this is 250 now. Okay, so this is 250. So this is 20 here. So these are the three things put together. Let me use a color code to tell you where the information comes from. There are three colors here. So first one is this color. Okay. Second one is this color. Third one is this color. And then the missing information happen, say the upper the anchor elevation. Okay, so first of all, find knots, right? So calculate the horizontal distance between the tower and the vessel. Okay, between tower. But before that, let's see what is the distance between, and the ship move to 5 o'clock to 1510, right? It's moving at 5 knots per hour. Okay, moving at 5 knots per hour. So let's try to understand this. Let me copy this thing diagram again. Okay, on the other page now. Don't this diagram. Copy wrong thing, right? Edit copy, select picture. Okay, so this is diagram. So let me calculate this again. Okay, first let's try to figure out what is V here. So let's call this distance AB. Okay, AB here. Between from 1700 to 1710. Okay, how far has the ship traveled here? The distance the ship travel is what now? AB, right? What is this AB now? Okay, first of all, distance is speed times time, right? Distance is speed times time. The speed is 5 knots. Now, 1 knot is 1 nautical mile per hour. So this is actually using this information. This is 1852 meter. Okay, so per hour here, and the time taken from 5 to 5:10, so it's actually 10 minutes here, 10 hours 60 minutes. Okay, so you multiply these two, so you get AB, the distance travel is A times speed times time. So you can get what? 5 times 1, 5, 5, and then times 10 hours 60 minutes, and then you can find that 1551 or 1552 lah. Okay, 1552 meter. So this distance here, AB, I can change it to 1 meter now. Okay, so that's to get the question there. The triangle, there's a ship at the point A at 5 o'clock, and then there's a tower.
Sir, I checked
Yes,
for the speed times time. How can I get 1543? I follow exactly the same.
1543. Let me see whether I got it correct. So 5 times 1852, right? Times 10 over 50. So 1843, yeah, sorry, correct. Yeah, 1843, yeah. So 1843, yeah, correct. Thank you very much. So this 1843.
1543.
1543, yeah, correct. Right? 1543. Okay, this 1543 now. Thank you very much. Okay, so 1543 meter is the distance between the ship from 5 o'clock to 5:10. Confirm, all right? How to find the distance AB, like the speed of time. The speed is 5 knot. 5 knot is 5 times 1852 meter per hour, given by the question.
Sir.
Yes.
Sorry, don't mind I ask, but how do you derive that the at the bearing 250? Why you call it B? How would I know whether it's B or C?
It doesn't matter. It doesn't matter. It's just give a name only. Doesn't matter why you call it B. Okay, just why I call the I must give a name for the triangle, right? Later on, then I can use it. So it doesn't matter which name you use. Okay, I just take the example. So the ship at the beginning at 5 o'clock is called, this location is A. Then when after 10 minutes, the location is B, and then the tower is called C. Just to of course you can do naming different way lah. So just ABC here. There's no reason why you give certain name. You you can just give the name of the ship A, ship B, in this case, or tower. Okay, doesn't matter. Important thing is the triangle must correct here. Okay, so now I want to move on. Calculate the distance. This first part now. This part. Calculate the distance in meter between tower and the vessel at the point at 5 o'clock. So what they want is the distance AC, right? Want AC now. So part A actually want to find distance AC. Is there a way to find out distance AC? Okay, then I have to okay, I want to find the distance AC, right? The angle elevation is 10 degree. Okay, so let's try to do calculation about the triangle first. Okay, that's triangle. Finish, continue, right? I need to find out more information about the triangle now. Okay, so otherwise you cannot do calculation actually. So at this select page here. So let me continue before I move on the question. So what are the information you know about this? So first of all, what is this angle? You can find out. Very easy one. -50 minus 30, right? So angle A is actually 50 minus 15, you get 35. Okay, so what else you need to know? Okay, then you also angle C. Angle C, you need to draw this here. Okay, angle C, you have 15 here. So angle C, I use a green color here. Okay, 15 here. Based on the green one, okay? 15 here. And then this is 90. And then this is 20. The blue one. So from here, you know angle C now. Okay, so get 90 plus 15 plus 20, get 125. Okay, so with this all information, what can I find AC now? Can I find AC enough from here? So AC is actually the side B, right? AC, so if I call this AC is a side B here, okay, B, so B here, and then this is the side C here, and then this is side A here, ABC, label ABC here. So that means that I want to find out what is AC, right? Calculate horizontal distance between tower and the vessel. So AC is actually a B here. Okay. Okay, AC is a B here, and then A is actually, I have no idea. Okay. Okay, then I can find out what is angle B, right? Because total angle of triangle is 180. So 180 minus angle A, angle C. Okay, so 180 minus 35 minus 125, you get 20. So this angle is 20 here. Good here. Okay, angle B is 20. Okay, so I also solve triangle already. So then I can calculate the distance between tower and the vessel at the, because I have all the angle already, should be no issue already. So let's copy this page here. Okay, so I can answer all the question now. And this for this part. First part, calculate horizontal distance between the tower and the vessel at 5 o'clock. So I want to find B now, okay? So B is the distance AC. Part A is looking for AC now. Okay, I can use the sine law. So, which is actually B equal to what, right? So, I can use B over sine B here. And then I can use A over sine A here. So B I don't know. So B, angle B I know is 20. A I know. Do you know A or not? I don't know. I use C, C I got answer. Okay, because I don't know what A here. So C is 1543. Angle C we find is 125, right? Okay, the double check. C 90 plus 20, 115 plus, okay, 15 plus 90 plus 20 is 125, right? Yeah, correct. So then you'll find that B is equal to 1543 times sine 20 over sine 125. So we calculate this one. Where's the distance now? Is 1543 times sine 20 divided by sine 125. $644. So this is how you answer part A. Again, when you after construct a triangle, usually you have to use a sine law or cosine law to help you figure the unknown things. Okay, so you have to pair them so that you can get them. Because initially I use A. The A, unfortunately, I don't know, so I must use C now. C is 1543. With the angle C, we know. So you must have something you know that you can continue work on. So I know the AC is 1644 now, okay? AC is 614. Okay, then I want to find out the height of a tower. Second part now. So I move on to find the height of a tower. Okay, I'll move on to the next page now. So now I want to answer the question part, second part now, the height of a tower. So I know B is 644 now. Let me erase this diagram now because I don't need bearing now. So there's another diagram. Okay. The ship at 5 o'clock is actually somewhere here. This is A here. Another diagram now. Ship at 5 o'clock. And then this one is picture now. It's a tower. C now. The tower has a height H here. Okay, now I will focus on this one. It's different question now because just now the triangle I draw is a bearing triangle. Okay, this time it's different triangle now. Okay, this time it's a different triangle. What the triangle about here is actually observe at 5 o'clock here. Observe that the angle elevation of the top of a vertical tower is 10 degrees. Okay, this is a statement now. Okay, so this is a different triangle now. Okay, it's physical triangle, not about bearing now. So the tower got the height there, and the angle elevation means this angle from the ship at 5 o'clock there. This angle elevation is 10 degrees. And we find that the distance B, right, this is AC here. AC in this case, C is a tower there. So AC we find out is 644. Okay, 644 meter is a distance for AC. Okay, this is a different triangle. Now it's not a bearing triangle. So now I know this 144 now. So let me erase this now. So how do I calculate the height of the tower here? So you using the right angle triangle. This one is height over 644, right? So what kind of function is that? So you can use that, okay? The height tangent of 10 degree is opposite over adjacent, right? This is opposite of 10 degree, okay? Opposite this adjacent. So this is opposite H here, adjacent is 644. So tangent 10 degree. Okay, opposite of adjacent is the tangent there. So the H they're looking for height there of the tower. Okay, height of the tower in this case is 644 tangent 10 degree. So this is a totally different triangle now because this triangle not about bearing, just now the was direction and bearing, right? So different triangle now. So it's 644 times tangent 10. 113.5. So 114 lah. This is how you answer as number 4. Okay, so this is example 4. Let's look at example 5. Okay, so let's look at example 5 now. So again, there are a few diagrams in example 5 when you look at the notes there. So let's try to look at this situation. I mean, this one a bit confusing because they try to draw you the physical diagram. So M and N are two different positions of a boat. Okay, so you can see M and N are boat. M here. Okay, there's one boat there. There's another boat here. So, and then there's a cliff somewhere in between there. The height is 44.6. So this one doesn't talk about bearing here. This one, okay, so 44.6 above sea level. Okay, so but this question not about the bearing. Then the next question tell you the bearing now. Okay, when the boat is at M, okay, when the boat is at M, the cliff is on the bearing of 250. Okay, so how do you draw that? Okay, let's draw it. Yeah. So this is M here, 250. Okay, okay, M 250 we already know a few times already. This is north here. So this 0, east, west, south. 250 is about here, 20 degree, right? So you get 250 here. So this is how at the M they see the cliff, right? The cliff is actually at this place. Let's call it C here. C is the cliff. Okay. So you look from the M, look at the cliff there. Okay, then you talk about anchor elevation later on, right? Then when the ship is at B, N. So another statement here. When the boat is at M now, the bearing is 0, 0, 0. What does it mean? Okay, 0, 0 means directly. Okay, this is M here. Somewhere here M is here, directly below. Because a bit confusing now. So North Pole here. So this angle here is 0, 0, right? Because this directly for North Pole, this is 0, 0, 0. So angle is actually 0, huh? So we need to write. Okay, this is directly on the north side of N. Okay, both N. So we know instead of drawing 0, 0, okay, 0, 0, 0 is on directly at the north. So this is 0, 0, 0. So bearing degree is 0, right? So this is how the diagram look like. So you can join the diagram from here to here, join together. This is about bearing. Okay, so this about bearing here, and then okay, now I'm going to look at another statement. The cliff height of the cliff is 446, right? First, I want to find out distance CN now. So let's draw another diagram. So this is where is find the distance CN, okay? So I'm going to use a different color one. So different color. Okay, angle elevation from N. Okay, angle elevation for N is 12 degree. So you can see from the diagram, the triangle. This is a triangle now. Right angle triangle. This is the cliff. The height of the cliff is 44.6 here. This is 12 degree. Okay, actually look at this triangle now. So where is the distance CN? So you can draw a calculation. So you can use tangent again. Tangent 12 degree is opposite over adjacent, which is 44.6 over CN, right? So you press a calculator. Okay, CN is 44.6 over tangent 12. So that gives you 44.6 divided by tangent 12. 209 or 210. So this means that this distance is 210 now. Okay. Distance CN is 210. Okay, so I find out this one already. Next, the thing is the bearing coming in again. Okay, so next page here. Okay, I'm gonna find an angle MCN here. So let me erase this now. MCM, angle MCM here, can I find? Okay, can I find angle MCM first? From triangle, from bearing here. So where is angle MCM? Is this angle here? So what is this angle? There are actually two portions here. One of them is how much is this one? So I can use a 250 here. So this one is actually the come from the yellow portion. So this angle is 9. This angle is 20. This angle is 20, right? So 20. Okay, so this is from the yellow yellow portion here, and then plus 90. Okay, so this part 90 here. So it's from 1 to log. So this is the part quite easy to find. And then I need to find this 110 here. I need to find finally the distance mm, right? So I need to know what is MC, right? So how to find MC here? You can draw another triangle here. Right? The MC, okay, you have M here, the C here, the height is 44.6, and the angle given here is 10. So this is another information given by the physical information here. So 10. So you can find out, okay, tangent 10 is actually opposite over adjacent, which is actually 44.6. Adjacent is MC. So that MC is equal to 44 over 10 degree. So we take 44.6 over 10 degree. Tangent 10 degree. Two five two or 253. Okay, so this is 253 now. Okay, they didn't ask you this part. I only ask you the angle MCN here, but you have to find out what is MC in this case. Finally, okay, once you got this already, then you are ready to find out what the distance between M and N now, okay, because now you have all the information now and the angle there. So I can continue. Select picture. Okay, the last part. Finally, I want to calculate mm now. So this is where you can apply cosine law. Okay, cosine law you can apply cosine law here, or you can apply sine law also can. So let me show you how to apply cosine law here. Okay, so last part. Okay, second part I finished already. The last part I want to find out what is the m here. So I can use a cosine law or sine law, up to you lah. Huh? So I can use the sine law. Okay, can I use sine law here? Since I know. Okay, MCM, MM here. Let's see. This one I find out angle A is 20. Okay, actually, I don't need to know what is okay. Actually, from here, you see that this is not necessary. Okay, this is not needed. Okay, I can find actually the answer without this information. Okay, so what I can use a sine law. Okay, sine law. So just now this angle we have found out m is 20 degree, right? So you can find out. Do we know that? Okay. Do you know that? Actually, no. Okay, this no 20 degree. No. So actually, I don't have the information. So let me use cosine law now. So mm square. So actually, we check here. So it's not need. It's actually not true. Okay. So you get mm square here. Okay. Okay, there are two sides here. One is 210 square. One is 253 square. Minus 210. 2 times 250. Okay. Minus 2 times 210 times 253 cosine 110. So we can get this answer. Let's see here. So 210 square. Okay, 210 square plus 253 square minus 2 times 210 times 253 times cosine 110 degree. Okay, get 1 4 4 4 5 2. So take a square root now. Take a square root. The answer is 380. Okay, so this answer the last part. Okay, so they are finished lesson. Thank you very much. So the lesson is recorded. Later on, I will WhatsApp you the lesson. Okay, so today we'll stop here. Tomorrow I see you again. Okay, so today I'll stop here. So because I rushed to another appointment already. Okay. Okay, so I will stop now.